All right, let's do another graph. So it's always good to start out with factored form. And so let's get this guy factored. 3x plus 1 already factored. The denominator, though, is x plus 2, x minus 1. And so with all the factors, we got access to some of our shortcuts. So factor everything in the top and the bottom. Now, one thing to notice is 3x plus 1 is all factored. And x plus 2 and x minus 1, everything's factored. And none of these factors on the top and bottom are the same. So I didn't make a big deal out of it on the previous example, but the first observation is this rational function has no holes. Holes would only happen if it was like x minus 1, x plus 2, x minus 1. If our function looked like that, we would have a hole at 1 because there's a top and the bottom the same. So that's kind of something that comes up occasionally, but not too often. But we don't have to worry about it. There's no holes. So the next thing I'm going to do is start finding my critical points, and one of them is the x-intercept point. Or let's do the y-intercept point first. Y-intercept point. Okay, so I'm going to plug in x equals 0. So we've got to do g of 0. And that means 3 times 0 plus 1 over 0 squared plus 0 minus 2, which is basically 1 over negative 2. And so my y-intercept point is 0, negative 1/2. Important point. We have no holes, and we've got a y-intercept point. This is 1. It's not perfectly graphed, but it's right down there at 0, no, minus 1/2. Okay, x-intercept points. This time y equals 0. Okay, now this involves one of the shortcuts. Do we have to worry about the top or the bottom or the division? Well, as you practice this, you'll start making those connections. But the bottom is going to have nothing to do with the equation solving to be solved for the number 0. Now that's different than vertical asymptotes where we don't want the bottom to be 0. But here, if we want the x-intercept points, it comes down to simply the top equation. And that's going to give us our intercept points. So if I minus 1 on both of these, and negative 1 equals 3x. So x equals negative 1/3. So now I've got negative 1/3 comma 0 is my x-intercept point. Oh man, that's not the nicest point for graphing. But roughly, when we graph, it's going to be over here. And so I'm going to fill that in. That point is negative 1/3, 0. Okay. Let's see. So we've got holes, y-intercept, x-intercept. What should we do next? Let's do the vertical asymptotes. So I had been doing those in purple. I'll just keep that going. So the vertical asymptotes, that also involves one of our shortcuts. I forgot to write this one down. That was a shortcut for the top. The vertical asymptotes is a shortcut involving the bottom. So we want to look at x plus 2 times x minus 1. And the bottom can never equal 0 for a fraction because you're dividing by 0. So this is going to tell us our domain restrictions, and it's going to tell us asymptotes. So if I have negative 2 here, that's going to make it equal 0. That's a violation. So it won't be in the domain. So my vertical asymptote equation is x equals negative 2 is the equation, is the equation of this line here. And it's a broken line where the graph will not cross. There's another one, x equals 1. That is this line right down here. Different vertical asymptotes. Next, first part of vertical asymptotes. Second part is about the tails. Now I have two asymptotes to look at, so I've got two sets of tails. But notice x plus 2 is degree 1. And so is x minus 1. So they're both degree 1. Which means on both, the tails are opposite. So if I go to the asymptote at -2, I'm going to have one tail up and the other down. Or if this one goes down, then this one has to go up. So I know that fact. On this -2 asymptote, my tails are opposites. And the same is true with that one. So if I know -2, this tail is up, then on this one, this tail is going to have to be down, and this tail is going to have to be up, or vice versa. On this asymptote at 1, I've got a tail up or tail down. And I don't have all the details yet, but we have other clues that are going to help us figure out these tails. But we know they go on each opposite asymptote in opposite directions. Okay, next, let's do the horizontal asymptote. Okay, now horizontal asymptotes, what does that involve? The top? No, we're going to use that already. That's for the intercept. The bottom is for the vertical asymptotes. This one is the dominant division. So I'm going to take the leading terms. There's my leader, 3x, and there's my other leader, x squared. And so that goes to whatever this does, 3 over x. Well, what is 3 over x? As x goes really big, 3 divided by a really big number is going to 0. That is my horizontal asymptote. Now I got better on this graph. I took the vertical ones off, but this one, the horizontal one, was still there. So there's my y equals 0 horizontal asymptote. Last question. Is it going to cross? And sometimes you can figure out the graph without looking at the cross. Does it cross the horizontal asymptote? You can if you're willing to plug in points. Now if you look in YouTube, you'll see a lot of instructors. They'll take a number really close to -2 and plug it in and see if it comes out positive or negative. And if it comes out positive, that's your clue. The graph has to go up. If it comes out negative, it has to go down. So you actually plug in a point. But sometimes plugging in a point that's, like -2.1 into this function, that's a pain. So we would need to solve for 0. Does 0 equal 3x plus 1 over x squared? But this, hey, wait, 0, that's the y-intercept point. We've actually already solved it. Now that's just a coincidence because this horizontal asymptote is on the y-axis, the x-axis. So we have found a place where it does cross. It crosses at -1/3, 0. Okay, and we can see it. It's right on, right here. It's right on the horizontal asymptote. It's got a cross there. Okay, but there's only one cross. When we solve this, there's only one solution. So I can't have another one that does this because that requires 2 crosses. That's not going to be possible. So we've got some strong clues here. When I do my graph, I got to connect the intercept point and I've got to cross. So It cannot go up again. The only thing I can do is connect these dots and then keep going down. That can't go back up again because that would make me cross a second time. So I just figured out this middle branch kind of looks like that. And I've also learned that the tails go in opposite directions. So on this side, if the tail is up, it forces this side. All right, I figured out this tail is going up. Sorry, I'm repeating myself here. Had a little technical difficulty. The only possibility is for the other tail to go down here. Now, it is not possible for me to cross because there's only one cross point here. So the tail and this branch have to be entirely below the asymptote. Now, when I figured out this middle branch had to connect these two dots, then I learned that, oh, this tail goes down, so this tail has to go up. And I can't be crossing again, so I've got to have a branch entirely above the asymptote. So with a little bit of logical reasoning, that's what I mean by analysis. We've been able to figure out a quick sketch of that graph, and we can see here what it's supposed to look like. There's the asymptotes, and there's the three branches. So my sketch, it's kind of sloppy, but it's really close to the real sketch of the rational function. Hope that helps. Got a couple more examples for you.